I became director of PCIGR basically when I joined UBC in 2002. Things have changed significantly since then because I ended up being in charge the year after. And I have an idea. Yet from the beginning, I wanted PCIGR to be an open facility. That is, anybody who is interested in doing research could contact us and we'll help them design research projects and potentially adapt our techniques to make this happen.
So here at PCIGR, I think we're unique in Canada because we have the ability to go from a rock in the field and to do everything from mineral separation to uranium-lead high-precision geochronology to high-definition SEM imaging to any kind of trace element or isotope you could possibly imagine, which is something that really doesn't exist anywhere else in Canada and allows researchers to come here and we can really tailor-make their project and help them answer their questions with any tool you could possibly imagine, which is very unique.
My main task involves research services together with my colleagues, and that comprises providing sample preparation, chemical and isotope analysis. So right now, we're working on the Osiris Rex mission. We were lucky enough to contribute to the chemical analysis, major and trace elements to the program. Meteorites have the disadvantage that they're always contaminated, whether it's the atmosphere, the gas, or any other terrestrial substances. While this sample was probed directly on the asteroid, was safely contained and brought back to Earth. And we're very excited and very honored to be part of that program. And the analysis will hopefully help us to understand the origin, the evolution, not only of the parent body of this asteroid, but also of our entire solar system and other planetary bodies in time and space. So how did our solar system evolve? How did the planets evolve? How did Earth evolve?
As the world looks to particularly decarbonise and electrify, we know that that infrastructure is going to be underpinned by minerals. So we know we're going to need more minerals. And with a lot of our new technology, we need different minerals that we haven't used as much in the past. Things like tellurium in solar panels, for example. So we're seeing a shift in the types of materials that we're consuming. In many cases, we don't have great models for how those deposits necessarily form because we haven't looked for those materials in the past. And so by developing new understanding of what geological processes form those deposits, we can develop new exploration strategies. And through our research on characterizing where those minerals are and what elements are associated with them that we can do here at MDAU and at PCIGR, we can really help to address that challenge.
As a student, you normally don't get the opportunity to go through, in general, you usually don't get the opportunity to go through and process and analyze your own samples. So that in and of itself is hugely important for future careers. The fact that I've also been able to be involved with setting up the methods within the lab to even start to analyze an element that literally doesn't happen. It's a really exciting opportunity. The experience of being able to set up a method within the lab, I'm going to be able to take that with me wherever I go and be able to do that in any lab.
PCIGR has a lot of amazing facilities and instrumentation, but because of the interdisciplinary nature of the research that we do, actually interacting with a lot of the research scientists and faculty at PCIGR has been a real benefit because it's helped me to not only get hands-on experience working with instruments and in lab spaces, but also working with other scientists with different perspectives.
So I am lucky enough in that all of the research and work that I have done in labs at PCIGR have actually equipped me enough to be hired or have a job lined up post my master's as a lab analyst, which are all things I wouldn't have been able to do if I hadn't gotten experience using the mass spec machines here and analyzing things like rare earth elements and lead isotopes. So all of the instrumentation, which are all very niche instruments that are not widely available around the country or even globally, are all instruments that are very exciting for me to be able to use and are transferable to other labs across the world.
We're open for motivated students to come and join our team. We have a huge range of things to work on, and we work at the cutting edge of analytical techniques. So if you like
hardcore isotope geochemistry, if you like low temperature applications, sedimentology, if you like tracking pollutants, if you like volcanoes, if you like erupting lava or mantle geochemistry, there's a little bit of something for everyone here. And it really is an inclusive environment that you can come and do good research and become better scientists overall.
I like the fact, and I worked on that, to provide a service to the community, something that other laboratories don't do. We need more facilities like this because geochemistry over the last 20 years has become a very important tool in earth science, environmental science, to document climate change, to document pollution, environmental impact, to search for critical metals. It's all related to the improvement of techniques.